Hello everyone, I'm Piri. I'm a member of the IMC team. Today I'm going to talk a bit about the First Lega League, so let's get started. First Lega League, or FLL, is an international engineering and science program designed for students between the ages of 9 and 14. But it would be incomplete to think of FLL as just a robotic competition. Because FLL is about much more than building robots. It teaches students how to think, experiment, make mistakes, and improve. Its main goal is to help students become creators of technology, not just consumers. In a way, we can see programs like this as a stepping stone to professional life. Here, we don't use something quickly. We design our own solutions, test them, and improve them. In this sense, FLL is an educational model that introduces engineering thinking at a young age. FLL consists of 4 main components: robot design, coding, the research project, and teamwork. These parts are not independent from each other. On the contrary, they complete one another. Together, they form what we call the FLL spirit, its main mission and vision. Robot design allows students to solve a problem physically through a system. Coding determines how that system behaves. The research project teaches students to develop scientific solutions to real-world problems. And teamwork ensures that all of this is done collaboratively, not individually. Success in FLL is not about building the fastest robot, but about developing all 4 areas in a balanced way. This is what makes FLL different from traditional robotics competitions. One of the most important features of FLL is that each year a real-world problem is selected along with a theme. This theme could be about the environment, health, or an engineering need. It forms the foundation of all robot missions and research projects that year. Thanks to this theme, students learn that robotics is not just a fun activity, but also a tool for solving real problems. For example, if the theme is ocean pollution, the robot missions may represent cleaning waste from the sea. In the project part, students suggest a solution that could be applied in real life. So FLL teaches students to see the robot not as a goal, but as a tool. At the center of learning in FLL is trial and error. Your robot will not work perfectly on the first try. The code might have mistakes, sensors might misread, or a robot might miss the line. But this is completely normal. In fact, it's not just specific to FLL. This is how life works. Engineering is not about being perfect. It's about identifying mistakes and fixing them. FLL gives students this mindset. If it doesn't work, don't give up. Improve it. That's why the process is always more important than the result. Students learn patience, systematic thinking, and problem solving. And this process is not just for one season. The skills learned here, coding, logic, problem solving, and teamwork, form the foundation for more advanced programs like FTC and FRC. But more importantly, FLL teaches students to answer one key question. There is a problem? How can I solve it? The ability is useful not only in engineering but in every aspect of life. That's why FLL is not just about robotics. It's about thinking and creating. Now let's look at how robots actually work. FLL robots have 4 main components: sensors, motors, the hub, and the chassis. Sensors collect data. Motors create movement. The hub acts as the brain, and the chassis is the structure that holds everything together. The hub is the center of the system. It processes data, runs the code, and sends commands to the motors. Without it, nothing works together. To understand a robot, we need to know one thing. Robots don't think on their own. They constantly repeat a cycle. This cycle has 3 steps. First, they receive information from the environment. Then they process and decide. Finally, they act. We call this the sensor code motor cycle. Everything we do in FLL is based on building the cycle correctly. Sensors allow the robot to understand its environment. Just like humans use their eyes and ears, robots use sensors. The most common ones are color sensors and distance sensors. Without sensors, the robot is essentially blind. After receiving data, the robot needs to code to interpret it. Code tells the robot what to do in certain situations. For example, if the color sensor detects black, the robot can be programmed to stop. Coding doesn't give the robot intelligence. It allows us to transfer our thinking to the robot. Once a decision is made, it is sent to the motors. Motors are responsible for all movement, moving forward, turning, or lifting mechanisms. Even if the code is perfect, if the motors are not placed correctly, the robot won't function properly. That's why mechanical design is just as important as coding. And this process keeps repeating. The robot continuously senses, decides, and acts. Success in FLL comes from making this cycle stable and repeatable. The force sensor measures pressure and can act like a button. The color sensor can detect colors or measure reflected light, which is very useful for line tracking. The distance sensor measures how far the robot is from objects. And the gyro sensor, built into the hub, helps the robot make precise turns. Motors act like muscles. Some provide a balance between speed and power, some focus on strength, and others are designed for precise movements. The chassis holds all parts in place. A good chassis should be stable, simple, and repeatable. Even small details like sensor placement or cable direction can affect performance. In FLL, we also use different mechanisms. For example, grabbers are used to pick up objects, gripping systems help the robot hold or climb, and linear mechanisms allow movement in a straight direction. These depend on creativity and design. Finally, coding brings everything together. Coding is the art of telling the robot what to do. It's not just placing blocks, it's about deciding what the robot should do in each situation. Without code, the robot is just a toy. With code, it becomes a system that reacts to its environment. In FLL, we use a block-based coding system with Lego Education Spike. Each block represents a command: moving motors, reading sensors, waiting, comparing, or making decisions. For example, we can program the robot so that when it detects a certain color, it performs a specific action. Or when a force sensor detects pressure, it triggers movement.
So we have a question here. The robot advances until it sees the red, and when it reaches the red, it starts the B engine for 1 round and moves forward 10 laps. You can pause the video and figure out what's wrong here.
Coding must be structured correctly. If a condition is not placed inside a loop, the robot checks it only once and then ignores it. That's why loops and conditions are essential. To make the robot constantly check sensor data, we use repeat loops or continuous conditions. This ensures the robot reacts correctly in real time. That's all I wanted to share about FLL. I hope this was helpful and informative for you. See you in FTC. Bye.